warahmatullahi wabarakatuh. My name is Hazim B1 Alida Fairuz. My metric number is AN190026. My supervisor is Dr. Nur Ain binti Sahari, and this is my title for my final year project, which is development of smart pH stabilizer for aquarium, fish tanks and fish tanks application. So we proceed to the next chapter, which is introduction. So for the introduction of smart pH stabilizer, smart pH stabilizer benefits to all fish lovers around the world to give a fish a better environment and a good quality of water all the time. The pH level in a tropical fish tank should be between 6.8 to 8.0, which is a neutral range. For this project, the smart pH stabilizer is built on Durian Uno, which combines electronic components to function the system to on and off, control the sensor and water change automatically. So for the system, ensures has balanced appropriate pH levels for the fish and aquatic life. So it is possible that the fish will die if the water gets excessively alkaline or acidic. This project is very eco-friendly to all users, thus it lessens the burden to take care of the fish to all human beings. So the result of the smart pH stabilizer, always make sure the water is in the suitable and safe pH range for the fish. Okay, for the next chapter, problem statement. So the problem statement in this project is majority people will still use the same method by handwork water changing. Maintaining an aquarium's water quality level in the appropriate range promotes fish development and decreases the occurrence of fish illness. Manual monitoring and replenishment of water is time intensive, and because water quality fluctuates frequently, it will not provide an accurate result. As the result, a smart pH stabilizer is being developed to address this issue. This system comprises of a pH sensor that detects the pH level of the water and a water pump that removes water from the aquarium. If the pH level is not within an acceptable range, the pump will cease functioning after a float sensor detects the water level in the sewage tank. And another water pump is installed in the water supply tank to replace and replenish the water in the aquarium with clean water until it reaches the desired pH level. Because water changes, this method can always provide good water quality for the fish. This project requires a very well-designed pipe system to allow the pump to operate at a high pressure, and highly pure and clean water was required for the water changes as well as chlorine-free water. So after that, the objective. So the objective of this project are to design a smart pH stabilizer for aquarium application which can monitor the pH level as well as automatic water changing. The second is to investigate the functionality and stability of the smart pH system. And lastly, to verify the performance of the operation via experimental setup. Next is our project scope. So the scope of the project is, this project focuses on researching and manufacturing a smart pH stabilizer to maintain the greatest water quality in a fish tank by reducing ammonia levels. As a result, the following is the project scope. Number 1 is specifically for aquatic fish in large aquariums, medium fiber tank glass, and small pond, estimated for 100 to 500 gallons of water. The second is a microcontroller will be used as the controller of the entire system to allow the system water changing to be done automatically. Number third is pH needed for the fish between 6.8 to 8.0 for the best quality of water needed. Lastly is 2 feet fish tank use and 2 containers for water change purposes. So for the literature review of this project, factor that causes water turbidity involving pH levels. Carbon dioxide and other chemicals such as nitrates may be absorbed by aquatic plants. Elevating pH levels, excess algae and slime should be checked on glass decorations and rocks. Second is tap water contains alkaline compounds and metals as well as other contaminants. As a result, most specialists advise against using untreated tap water in aquariums. Third is overfeeding can raise the pH level of the tank, and the fish pellet can also elevate the turbidity. And lastly, the pH levels can be raised by the presence of fish excrement. To eliminate fish waste as effectively as possible, a filtration system must be installed within the aquarium. So next is our project flow. So this is the flowchart of the system. So this explanation is for the flowchart of the project. So when the pH of the water changes, the process is initiated. The water pump 1 is turned on when the pH sensor notices tainted water in the aquarium. In order to prevent the water pump from completely draining the tank, a float sensor was attached. Due to the fact that there will still be fish in the aquarium, some of the water will not be forced out completely. The aquarium is continuously filled with new treated water by water pump 2 when the float sensor detects the water level in the sewage tank. So doing so until the pH reaches 6.8 to 8.0. To prevent the water from overflowing, another float sensor was added in the tank. If the process fails, it will be repeated. The procedure will be repeated if the pH level value stays outside the range, which is why it is called a smart pH stabilizer. So this is the 3D design concept using AutoCAD. You can see the design of aquarium fish tanks, an aquarium stand, a durian owner microcontroller box, and electronic parts like pH sensor, water pumps, and other parts are all included in this 3D AutoCAD model of a smart pH stabilizer. The fact that this size is low-cost outdoor-only design made it the best option. It is the size of a typical aquarium, so it is just the right size. Underneath the aquarium fish tanks, there are 2 separate sections of sewage and purified water storage tanks. The treated supply water tank and the aquarium fish tanks will each have 2 water pumps at the bottom of the aquarium. There is an aquarium water pump whose purpose is to remove all the fish waste. So next is the circuit and block diagram of this project. So the result and the discussion. For the result of our study, the fish tank will automatically clean itself when the pH level fluctuates. According to the presence sensor, the time it takes to change the water relies on the float sensor. This can lower the amount of labor needed to maintain the water's quality through cleaning and water changes. To guarantee that the fish tank is free of bacteria and chlorine, the water supply will mix with an anti-chlorine substances and maintain a steady pH. two water tanks will be there, one for the fish tank sewage and the other for clean water supply. The numerous components of the system may be changed, including the sensor that measures pH. Scalable and supportive technology is the end of the outcome. With the help of the sensor, the system will constantly monitor the pH level in the fish tank and keep it in excellent shape. The pH level in the aquarium will be shown and monitored on an LCD installed in a junction box beside the aquarium. So this is my final setup of the hardware of this project. So for the discussion, this is the graph data collected from 5 testing of the project. The result is taken by 5 times of testing to see the stability of the pH value in the fish tank. The condition following 5 water changes, the fish tank's pH level is steady because of the positive findings from all the tests. The pH level, which is 7, is still within the neutral range. To ensure pH stability, the process will be repeated if the result is more than 8 or lower than 6.7. Due to the coding is set in the microcontroller, more specifically known as the Durian Uno. From the observation, the system is very eco-friendly and very functioning as well. The graph built by the previous data collected by the pH sensor, the pH value in the aquarium is stable, shown in the graph. The graph line is slightly increased and decreased in every test conducted. So, for the conclusion of this project, finally, a smart pH stabilizer generates clean water for aquatic life by automatically adjusting the pH value in the aquarium tank, so that the fish do not become stressed as a result of the pH water levels being too high or too low. Due to poor quality produced by fish droppings, feces, and abundant food, the pH value is unstable. The water quality deteriorates when the fish feces begin to produce germs that can infect the fish. That is why maintaining a constant pH value necessitates water changes. Without any operator involvement, this pH stabilizer would operate when the pH value hits the maximum or lowest level by water change. There will be 2 water pumps, one to drain the dirty water from the well and the other to fill the well with pure water. 2 water pumps will be installed, one to drain the aquarium's dirty water and the other to give the anti-chlorine water. This project is always being upgraded to ensure that aquatic life has the access to high quality water. So this is the Gantt chart of the project. And this is the references. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So this is my video demonstration. So first of all, this is my final setup for the hardware of my project, which is development of pH stabilizer for aquarium fish tank application. So an acidic solution is tested in this aquarium to see the pH drop in the aquarium. So the water pump went on to drain the contaminated water into the sewage tank. We can see that the water is flowing in the sewage tank. The water will rise until it reaches the float sensor to stop the water pump from pumping out the water. This is the junction box installed beside the aquarium with all the components mentioned. After a few minutes, the water will reach the float sensor. After it detects the water level, water pump 2 will turn on and pumping in the clean water supply into the aquarium fish tank. We can see the water pump 12 volt is pumping in the water there. This process may take times according to the size of the fish tank. The water pump in the clean water supply tank will stop after the float sensor detect the water level in the aquarium. We can see that the pH is within its range, and that's all.